Thank you for coming to this presentation or watching this online. My name is Sean Hogston. I am the SE manager for the Southeast for Ruckus, and I'm going to talk a little bit today about 6 gigahertz standard power. Here at the conference this year, we've had a lot of presentations around 6 gigahertz, the challenges that we faced, things like that, especially around standard power, as that came out a little bit later last year from when we were here before. So I just wanted to kind of go over a few things when you're designing for networks that are going to include 6 gigahertz specifically. Some things you need to look out for and be aware of and just kind of plan for, because it is a little bit different than what we've done in the past, even with the upgrades, adding 5 gig and stuff. So as a little bit of a recap, what do we get with 6 gigahertz? So we got about 1200 megahertz of spectrum across, Uni 5, 6, 7, and 8. So in that, we've got to compete as well with the incumbents, right? So this shows a little bit of kind of what's in there, right? Fixed microwave stuff. There's some radio broadcast systems and things like that. So depending on where you are, that's what you're going to have to contend with whenever you're operating in 6 gigahertz. So for the folks doing indoor, that's not really that big a deal. It's low power. But when we start talking about standard power and going outside, then we have to consider these things, as well as just the fact that, you can see here with indoor, this low power only, we have the full 1200 megahertz of spectrum. But when you start going to standard power, you've only got the first section here in Uni 5, and then your sections back here in 7 and 8. So you have this, kind of break in there where you can't operate, but just in 5 and actually 7. So you're not getting the same 1200 megahertz of spectrum when you're dealing with standard power. So what are the things that we need to consider? So coverage, obviously, we're going to run low power indoor or standard power, client types, infrastructure, those kinds of things. So we'll talk about a few of these. And for the coverage side, I just kind of did, this is actual survey data. So we set up an access point that was running in 5 gigahertz only and did a survey in an office. I showed this before in the previous talk, so some of you will be familiar with this, but basically this showed what the coverage was like in the real world in an office from a 5 gigahertz radio. And then we did the same thing with 6 gigahertz that was running in LPI. So obviously you can see there's a good, considerable coverage distance just based on the power and the attenuation from 6 gigahertz. So when we get to the actual channel bands here, we're going to talk about a few things, but the big things that we're looking at is, we've got now, 59 channels when you're running in 20 megahertz, all the way up through 3 channels if you're doing 320. That's not quite so feasible because down here, if you're going to try to operate on this channel in the middle, you're not going to be able to do standard power if you're running 320 because you've got this break here. So the 320 actually goes across. Realistically, you would only get 2 channels. So you also have things like, the puncturing and things like that. Jim Palmer's talked a lot about that, and even this year at the conference. So I'm not going to go into a bunch of those as far as what they'll entail. But for AFC in relation and trying to make the decision, do I want to run LPI or do I want to try to run standard power? There's a few things to remember here. So if I'm doing LPI, I don't have to worry about AFC. So there's no extra requirement there. If I'm going to run standard power, you will have to run AFC, and that's regardless if it's indoors or not. If it's outdoors, it has to be standard power and it has to have AFC. So you don't really get a choice there. But here you got kind of the differences in power levels. You have, like I said, the entire 1200 megahertz spectrum available versus only 850 if you're running standard power. And then devices we'll talk about in just a second, is one of the things that you have to look at. Like, what are the client devices? Have you done testing on those devices to make sure they're going to actually work in a standard power environment? So that's something as well to kind of consider. So, and it's more than just, are the clients backwards compatible or not? If you set up your network for standard power and you have a client that doesn't support that, he may not even see it. He'll just ignore that thing altogether. And we'll talk about that in just a second. So the other piece that you need if you're going to run AFC is the locationing, right? So in the outdoor ones, our outdoor access points that have a GPS module, this is not really a big deal because they're outdoors. GPS will pick them up, no problem. They'll report their location and everything is great. But when you move indoors, you may have some APs that can receive a GPS signal, but not all of them, right? Especially when you get to the interior of an office space, or you get underground buildings, basements, or even some high rises that are just large enough to where in the center of the building, you're just not getting a signal. So we have to have some way of doing GPS locationing, and because that's the only thing that's approved right now. So for that, what we do, and this is the solution that Ruckus uses, other vendors will use a different type of solution, but for us, we'll place those APs around, and then they'll come up initially in LPI mode, obviously. And then with our mobile app, you can set the location for some of these anchor access points. So like ones that are close to the building edge, maybe they can get a good GPS signal. But with the phone app, the mobile app, you can set the location on the access point. The AP will then use 11MC to figure out all the other access points. So they're all figuring out where they're located, what clients are around them and that kind of thing. And then they'll send all that information up to the controller. So once the controller has it, he sends it over to the AFC proxy. That system does all of its checks, looks for incumbents and things, sends a response back. The controller will send that response back down to the access points. And then the access points will take that information, switch to standard power, whatever channel and power level that they were told that they can use. They'll make that selection and then switch over to SP. So the other thing to remember is that, like I said before, you need to make sure clients support that. But in our case, what we also do is we look at what's the power level that you're going to get from that standard power response, and is that power level the same or more than LPI? Because you could get a response from AFC that says your power level for standard power may be actually lower than what you're getting by default with LPI. So, and our access point would then just stay on LPI and not switch over. So that way you don't end up, hurting yourself. So client devices. So you basically have two types of clients. The 6XDs are the indoor client, low power, indoor only, and then your 6CDs, which will do dual power, right? LPI and standard power. So each of these guys, depending on what the client is, this is what you want to really consider when you're looking at going to standard power. You need to do some investigation. A lot of people have talked about this, at the conference this year, that you need to make sure the clients are going to support this. And then maybe at a minimum, you have some type of legacy environment that's another network setup at SSID or something that's not running standard power, because you need to make sure that these clients can get on if you have to support some of these things. So there's a link at the bottom. I know Chris Clemens talked quite a bit about AFC today, earlier today. So check out his talk. He goes into a lot more detail specifically about the AFC stuff and those requirements that are out there for 6 gigahertz. But here, the link is at the bottom. If you want to look up a device, you can see what that device is rated for. All right, so now let's talk just real quick. I know we're running kind of short on time here. The last thing I wanted to hit on was your PoE. So PoE with these access points, obviously they're being a much higher, higher powered APs. You need to look at how much PoE wattage you're going to use and what's going to be required for those. Make sure that the infrastructure underneath can handle that additional PoE draw. And then while you're looking at switches, also look at your switch speeds themselves. Make sure that the bandwidth for the access points is going to be capable. Making sure we're not running out of uplink from the access point, and then across as well. When you start looking at these higher bandwidth access points, all these things are going to add up. And then that link from your edge switches up to your aggregation and or core switches, you need to make sure all of those things as well are going to be supporting enough bandwidth to make sure that you're not going to have a bad performance. You don't want to upgrade the access points and then your uplinks are low and end up having a really poor user experience. So make sure you check that across to make sure everything is covered. And then while you're doing that, also make sure your cabling is current. In Prague, I believe it was, when we were talking about the test results, Jim Palmer and I did, we found some issues with cabling and wasted quite a bit of time troubleshooting that to find out that it was just a 5E patch cable that was in the middle of our link. So make sure you check those things out. So those are just some of the kind of things I wanted to kind of reiterate on real quickly and make sure people are thinking about, everybody's talking about the spectrum and the 6 gigahertz stuff, but just make sure that you're thinking about these other pieces when you want to go and actually get these things rolled out to a customer. So it's definitely worth doing some type of proof of concept, get that stuff tested, and make sure that you're going to have all your bases covered. So that's it. We'll wrap it up. Thank you.